Hello everyone. In this video, I will teach you about Abaqus at 3D Methods. This is my problem that I have given you. You can see it. Now, let's make 3D for this. First, you create part. You click here. Choose 3D. Choose Deformable. Choose Solid. In approximate size, I take value as 2. Why? Because I'm using SI units, and you can see here the maximum value of this object is 200 millimeters. Now, create section. You choose here. This is add dimension. You can see the value and change it. Let's make the value like the section of the problem. You see, height is 20 millimeters and width is 25 millimeters. Because I use SI unit, so we have to change value to meter. Height is 0.02 meter. Width is 0.025 meter. Click Done. The value of length is 200 millimeters, so it becomes 0.2 meters. Next, go to Property. Choose Create Material. For this problem, choose Mechanical, then Elastic and Elastic. I choose the material to be steel, so the Young's modulus is 200 gigapascals. You can choose other materials and find the suits Young's modulus for it. Poisson's ratio is 0.3 for normal materials. Then, create section. Solid, homogeneous, and click Continue. Click OK. After that, choose the assigned section. Take all the parts and click Done. When it turns green, that means your work is right. The next step is assembly. You choose the first one and choose Dependent. If you take the approximate size large, you will see your part is small. So taking the right size gives you more convenience. Then, you go to the step. In here, choose Static and click OK. In this window, you can choose the time period. You can try changing it and see what happens in the last step. Now, you come to the most important steps in this problem, load. This is create load. Click here, you will see this window. On my problem, you see this has a unit of Pascal, so this is pressure. You choose pressure and click continue. Choose the surface that pressure apply. You have to choose the right surface to get the right value. So I'm trying to give you to see that I take a right surface like in the problem.
Once upon a time, in a kingdom far, far away, when men were still men, women were still virgins, and sex was still...
When you're sure about your surface, click Done. The value for it is 0.5 megapascals. In Abaqus you put 0.5 E6. Then you choose Boundary Conditions. Choose Symmetry and click Continue. In this problem, one end is fixed and one end is free. So I choose this surface to become fixed. Choose the last one to fix all directions. Go to Mesh, click on the part on the top, and then your object become green. That shows you can mesh this object. Choose the seed part. Now you can mesh it. I will take a large mesh first. Now you click Apply and OK. Choose the icon below. This is mesh part. Now click OK. You can see here 10 elements have been generated. It's larger than I expected. so I will change a little bit. Now we have 80 elements. The last come to job. Click the icon PC. Now I want to change the name. You can keep the name, but in Abacus, when you do a lot of jobs, you need to change the name. That's really a key. In this slide, keep the default. Choose the next icon. Choose the data check. For the first run, you always take the data check to find the error. When it's complete, click to the submit. Now you wait. For the large mesh, it runs fast. With small mesh and a large number of elements, it takes more time. Now you choose the results. Click here to see the data. You can choose the kind of data you're looking for. I will teach you about how you know you do wrong or right with the theoretical in Abacus. This is an Excel file in which I calculate the value of the theory in the problem. To solve the problem, you have to calculate the inertia, and this is the formula for it. In here, B is width, H is height, and L is length. I is inertia, E is Young's modulus, and so on. For this formula, you can calculate the moment of inertia. I calculate for you in here, and you can see the code. Now you have to figure out what kind of problems. This problem is situation 3. Now you can calculate the displacement for this. You can see this formula in here. So this is the value for displacement. The W in here is not a force. It is a force divided by length, and I sign here as load W. You can see last video in 1D for more detail. To calculate the force, you divide the pressure by the area that P applies to. And this is this area. For stress and strain, I give you the formula to calculate in this picture in the file, so you can see it. Now let's check the value on Abacus. Mesh in here gives us 80 elements, so I will put 80 in the Excel file. The value U in here means displacement. Take the highest value and record it in the file. The value S means stress. The value E means strain. Different with 1D methods, now you can find strain. Something's wrong in my error for strain. Let me fix it. Okay, now you see the real value and theory value. The error is so high, right? Now what happened when I change the mesh, make it smaller? Now we have 12,000 elements. Let's run a job again. You can submit it now without any need to check again. For more elements, more time to run. You can see all my code for calculating each one. It's done. Go to results. Now you see the value is different. I will record it again and see the change in error.
Just a smile and the rain is gone. Can hardly believe it, yeah. There's an angel standing next to me, reaching for my heart. Just a smile and there's no way back. Can hardly believe it, but there's an angel calling me, reaching for my heart. I know that I'll be okay now. This time it's real. I lay my love on you. It's all I wanna do. Every time I breathe, I feel brand new. You open
Now you see the real value is close to the theory, so your work is right. That means a small mesh is more precise. I taught you 2 methods. You can see the difference with each one and choose the method to use. That's all for today. See you later.